All right, let's look at the first type of problem. The problem that says how much is left. They're either going to give you the percent or the mass, and they're going to ask you to figure out the new percent. It starts at 100 and drops to something new. It starts at a certain mass that they give you, and it drops to something new. You have to figure out what the new percent or the new mass is. Now, the problem is going to tell you the number of half-lives or the time period, and if it gives you the time period, you're going to have to do a quick little conversion to figure out number of half-lives. This is awesome. This requires a little bit of work. You want to see half-lives because it's easy to think about it in terms of half-lives. So let's look at this problem. Imagine that you had 1 gram, and 1 half-life goes by, 1 unit. Now you know that 1 is going to be cut in half, so it's going to go down to 0.5 or 50%. And then it's going to be cut in half when another half-life goes by, and so forth. So if you know how many half-lives go by, if the problem gives it to you, which is awesome, or if you convert, then you just keep taking your number and cutting it in half. Divide by 2, divide by 2, divide by 2. You just have to first off know how many half-lives. And again, you want the problem to tell you half-lives. If not, you got to convert to half-lives. But that's easy. We can use dimensional analysis for that. So let's take a look at this problem. We're going to look at it two ways. The easy way, I'm giving you half-lives, and we're going to look at it in terms of, a certain time period, but we'll get to that in a minute. Let's look in terms of half-lives. So we got 8 milligram sample. How much? So again, here's that how much is going to be left problem. So you write down what you start with. You start with 8 milligrams. And you know it's going to decay. And 3 half-lives are going to pass. So 8 divided by 2 leaves you with 4. That's 1 half-life. The second half-life divided by 2, you're going to have 2 grams left, or milligrams. And then the third half-life passes by. Now you have 1. So if you were to draw a curve here, 1, 2, 3 half-lives, you go from 8 at the top down to 4, and then cut it in half. Now you're down to 2, and then cut it in half, and now you're down to 1. So that's what your curve would look like, and this is what your numbers would look like. 8 down to 4, down to 2, down to 1. 1 gram is going to be left. How much? 1. Now let's look at it in terms of days. What if the problem gives you a time period and not half-lives? Half-lives are awesome, but what if it gives you days? Now it says a half-life of iodine 131 is 8 days. So let's figure out how many half-lives that is. Now I know this is kind of easy and you could probably figure it out in your head, but let me show you a method to rely on. So when the numbers aren't so nice, you have something that you can depend on. You write down the fact that you got 24 days and you want to convert to half-lives. So let's just write HL, half-lives. So what do? You put days on the bottom. Normal old dimensional analysis. So days on the bottom, we want to convert to half-lives, so put that on top. We know that 1 half-life of iodine is 8 days. 1 half-life, 8 days. 24 times 1 divided by 8 is 3 half-lives. So now you go back to the basic problem. You got 8 milligrams, and you divide it by 2 3 times, because you have 3 half-lives. And finally, 1.0. So 1 half-life, which is really 8 days. 2 half-lives, which is now up to day 16. 3 half-lives, which is now up to day 24. So after 24 days, we have 1 milligram left over. So it's the same problem, it's just looking at it in 2 different ways. Again, you like it when the problem tells you half-lives, but if it doesn't, if it gives you an actual time period, you have to look around and figure out what the half-life is, convert it from that time period into half-lives, and then go ahead and bang out the problem. All right, let's look at another one here. Potassium-40 has been used to date inorganic samples such as rocks since its half-life is so long, 1.28 billion years. What percentage of K40 will remain after 2.5 billion years and then after 5.12 billion years? Now, I don't tell you how many half-lives are passing, but I do tell you that you're going to start with potassium-40. Again, I don't even give you the mass. So you're going to assume percent. 100% is what we start with. If I give you, or if you see the word percent in there at all, write down 100. That's what we start with. Now, time is going to pass. 1.28 billion years is going to pass. That's the first half-life. Now we're down to 50. Then another 1.28 billion years passes. So 1.8 or 1.28 plus 1.28 is 2.56 billion years. and that's our second half-life. And now we're down to 25%. So after 2.56, we have 25% left. So what percent will be left after 2.5 billion years? 25%. Now, I did this a little bit differently than I explained in the slide before in case this works better for you. Just keep adding up whatever the half-lives are and keep a running total. Or you can do it like I said. We don't know how many half-lives 2.56 billion years is. So we're going to do out-dimensional analysis. 2.56 billion years, put billion years on the bottom. And then we're going to put half-life, HL, on top because we want to solve for half-lives. We know one half-life is 1.28 billion years. 2.56 times 1 divided by that is 2. So we know 2 half-lives have to pass. 1 to get us down to 50%, 2 to get us to 25%. So that's how you would do this one. Now, let's erase this and let's do the second problem. The second problem says, how much after 5.12 billion years? Well, I don't know how many half-lives that is, so I'm going to do a quick DA problem. 5.12 billion years. Put billion years down here. I'm going to put half-life on top. I know one half-life is 1.28 billion years for potassium. 5.12 times 1 divided by that is 4. So now I know I need to cut this in half 4 times. 1, 2, 3, 4. So what are my numbers? 100 cut in half, just take out your calculator, brings you to 50%. 50% cut in half, 25%. 25 cut in half, 12.5. And 12.5 cut in half, 6.25%. So basically, after 5.12 billion years, which is 4 half-lives, the problem would have been a lot easier if I just said, after 4 half-lives, how much would you have left? But if you don't see half-lives, you got to do a quick conversion. Get it to half-lives, and then that's how many times you cut it in half. 6.25 is our remaining percent. All right, try one more problem. Consider radon. Remember, we talked about radon not being a good thing to have in your basement. Consider a radon sample that originally contained 2.4 milligrams of radon-222. How much radon-222 will be contained? Again, here's our how much problem. How much radon will be contained in the sample after a certain time period? So I'm giving you time period, not half-lives. It would be easier if I gave you half-lives, but I didn't. So we're going to have to do some conversion. But we know that we start with 2.4 milligrams of radon. And we want to know, where does it end up down here? How much is going to be left after a certain time period? So 11.4 days. Now the half-life of radon is 3.8. You could just Google that. 3.8 days is 1 half-life. So 11.4 divided by 3.8, that's 3 half-lives. Now we just take this number and divide it by 2 3 times. 2.4 cut in half, 1.2. That's 1 half-life. That's 3.8 days that went by. The second half-life, 1.2 divided by half, or divided by 2 is 0.6. And then the third half-life, 0.3. So now I know after 11.43 days, 11.4 days, which is really 3 half-lives, I'm going to have 0.3 milligrams of my radon left. So again, just to kind of summarize here, what we did was we looked at 3 different problems. We always calculated how much is left. We had our starting value up here, and then we had to figure out, where are we on this curve? Are we after 1 half-life? Are we here after 2 half-lives, 3 half-lives? How much did it go down to after a certain time period has passed? Now the problem's going to give you half-lives. You like half-lives. Or it's going to give you a certain time period. Then you have to convert to half-lives. And that tells you how many times you want to cut it by 2. Keep dividing by 2, divide by 2, divide by 2, however many times, and that's your final value. And remember, if it gives you percent, you're always going to start with 100%. Assume you have it all at time 0. And if it gives you mass, that's your starting mass. Put that up top, and then just keep dividing by 2.